So in this video, we're going to learn about what a binary actually looks like. So in the last video I said about when you create a C project, you can have loads of different files, and then when they get compiled, they all get compiled together into a single binary. So today I thought we'd take a look at what a binary actually looks like. So what I'm going to do is I'm going to create a simple binary. I'm just going to print, hello world. That's all I'm going to print, because it'll be an easy thing to find in the binary. Then what we're going to do is we're going to obviously compile it, so gcc learn.c-learn, and we'll run it, and you'll see we get hello world printed out to us. So if I just drag this in, we get the up-to-date binary. So this is what a binary actually looks like. This is the contents of the binary, all the ones and zeros, printed out in hex format. So these are actually all just ones and zeros. That's exactly what a binary is. This is just formatted differently to make it easier to read, because it's actually a massive file. So to see what a binary actually looks like in a format that's actually usable, we need to use something called a hex editor. So I've got one here called iHex. There's just a hex editor I got for free on the Mac App Store. There's loads of free ones. You can get free ones for Windows as well. So just download a free hex editor and then open your binary in it. So the way we do that is just click File, Open Recent. I'm just going to open Learn. And let's just close this one. Okay, so here we've opened the binary, and you can see on the right hand side here we actually have some readable text. So if we just scroll through this, you can see here's our string that we're printing out. Here's hello world. So if I go back to the terminal and I run this again, you'll see it says hello world. But if I go into the hex editor and I change this to say, let's say high code, and you can see as well in real time on the other side. So you can see whenever I select stuff on this side, this is what I'm selecting on this side. So this is the code for hello. Let's say hello high code. Save this, and we'll run this, and we get a segmentation fault. So the reason we got the segmentation fault is it's probably hard to see it first, but the reason is because before a string is printed out, the size of the string is also is pre-printed before it. So even though we can't see it internally in the computer, it sees the size of the string, and then it knows how much memory to allocate for that string when it tries to do anything with it. So what I've just done is I've replaced this with a string that's longer than the original string, which is what caused our segmentation fault. If I save this and run it, we'll get hello world. But if I go back to the hex editor and I change this to say hello, so if I change this to say hello world, I'll just spell world wrong, so I'll change the R to an E and save this. We will get hello world with an E instead of an R. But you see if we go into the hex editor and change this back to world, let's go, actually let's just change this whole string. So this is an 11 character string, so I'll just change this to Francis space MCN. That is 11 characters too. If we run this, you see we get Francis MCN. If I try to go back to the hex editor and I put another letter in, you'll see we'll get a segmentation fault. That's because the size of the string is obviously too big for the size that's specified before the string. So if we wanted to add this extra letter, we'd have to find the beginning of the string here, which is here. We'd have to replace this number with another number. That would let us have a longer string. But what I'm going to do is I'm just going to leave it there, put this back to an or MCN, and run this again. You'll see we get the same output, and the program runs. So that's just been a quick look at binaries and what you can actually look at. If we change any of the ones and zeros, if we actually knew what we were doing and we changed them properly, we could make the binary do whatever we wanted. You can do this with any program on your computer, because any program on your computer is a binary file. So you can modify any binary file and make it do whatever you want, so long as you know what you're doing. Otherwise you'll break it, obviously. But thanks for watching, and I'll see you next time.